Alright, today I'm going to demonstrate a new pocket computer, the TRS-80 Pocket Computer, otherwise known as the Sharp PC-1211. And later on, when Radio Shack released the PC-2, or the second pocket computer, this became known as the PC-1. So this is the first pocket computer Radio Shack sold. It's really made by Sharp, the Sharp PC-1211. The PC-1210 was its predecessor, and these were amongst the very first pocket computers to support basic programming. There was a Casio model, the FX702P, which I've done a video on for support with the PCUI. That was Casio's first basic programmable calculator or pocket computer. Now, what I like about this one is, one, I'm more familiar with and have a appreciation and historical reference with the Radio Shack pocket computers. But this one has a QWERTY keyboard layout, whereas the Casio one just went A, B, C, D, you know. They didn't quite figure out the optimized layout, so I kind of prefer this model. Has a great display. I've actually replaced the LCD on this. I've written a blog post a few years ago on this. So this model's working great. This is my more heavily used model, I'll just say. We have some battery corrosion that had leaked through. So I have a few of these in perfect working order, but this is the one I've decided to donate for the, or volunteer for the experimentation here. So let's get started. So the PCUI, or Pocket Computer Universal Interface, is here. This is a project I started a while back, and if you haven't seen any of the previous videos, then a quick introduction is in order here. The PCUI is a single standalone device that will connect to multiple pocket computers, hence the word universal. And I'm adding support for various pocket computer models fairly regularly. And the purpose of the PCUI, or this project, is to provide printer and or cassette interface support for vintage pocket computers, calculators, where those printers and cassette interfaces are difficult to find or expensive, or maybe the paper that the printer uses is hard to get, like in the case of aluminum coated paper on the Casio FX702P, for example. Perhaps it uses pens, plotters that are hard to get working again. And even if you can find these things, they're quite expensive. So here's an example of the cassette and printer interface for this particular model. You know, they're fairly easy to come by, but again, they're not that, they're a little bit expensive. So the PCUI kind of fills that gap and provides that vintage printer support. And the other thing it provides is on a micro SD card storage for your programs and your data variables. So instead of using a cassette recorder, it loads directly onto SD card, and you can transfer from SD card back to the pocket computer. So the PCUI can support more modern printers, either parallel or serial. Basic line printers will work just fine. So in this case, I'm using an Epson receipt printer, thermal, very inexpensive. Paper is very inexpensive. You could use a vintage dot matrix printer. All sorts of possibilities there. So the PCUI has a very basic OLED screen for the interface, 4 hotkeys that are changing. The context can change depending on the screen or menu that you're on, and then a whole bunch of status LEDs here. So the connectors to pocket computers, there are 3 different connections provided on the PCUI. So we have a 3.3 volt level, a 5 volt TTL level, and then a TI graph link. So this version of the PCUI supports various connection methods. And normally, when I have support working for a pocket computer that's different than the others, I'll create what I call an interface pack, or a connection pack. So here's an example of a Casio FX502P, 602P, 702P. What happens is this end would go into the pocket computer, and then the other end goes into the ribbon cable for the PCUI. And what this allows for is a single device like this to connect to multiple pocket computers. So in this example, I have a standard DuPont style series of connections going from the 9-pin interface on the side here, which normally gets connected to the printer and cassette interface. I have that temporarily connected directly to the PCUI like this. And once the connection pack is made up, and I have a couple of PCBs custom made, I'll have a proper connection. But until then, this will do just fine. So let's demo something very quick, simple. First I'll demo the printer support. So I will press the printer command here on the menu, and this printer that I'm currently using is an Epson thermal receipt printer, and I have it connected to the serial port. I also have a parallel port version of that printer, a USB version. There's a whole bunch of different versions, but this one is the one I have on the desk today and that I've been using for most of these projects. And what I'm going to do here is I'm going to run a program that I've put in the Pocket Computer. This is the banner program. I usually write these for testing the printers for the various Pocket Computers. So I'll go ahead and run the program. And it's asking for letter by letter. It's a limitation of the amount of memory in here and the basic functions that are available. I can't input a whole string of characters, so I have to go letter by letter to print the banner. So what I will do is I will type in the letter A, and we'll press enter. And what's going to happen is the Pocket Computer is running its program. It's a little bit slow on this model, but it's going to print an A in a banner style, so a larger text output format. And we can see the status LEDs, one for the Pocket Computer interface and the other for the RS-232 interface. So those will light up when data is going in either direction. And the printer is printing, albeit at a slow rate. The PC-1 is not the fastest Pocket Computer in the line. And let's see if this prints out the letter A. One thing to mention, I do have the scaling in the Pocket Computer and the PCUI. There's a menu setting for adjusting the scaling. Normally this is a 16-pin, this is a 16 character wide printer that came with this model. So we have much more real estate to play with on the Epson. So I use there's an Epson command to make to scale the font a little bit bigger so that this A prints out a little bit more of the real estate that's available. So that's a setting in the PCUI. Otherwise it'd be rather small characters. So I'm going to go ahead and press the menu button to cut the paper, and we can see we have the letter A printed. So one of the basic features of the PCUI with this model is working as expected. Okay, on to the next item to demonstrate here. I'll put my letter A aside here. All right, so the next feature set that I'd like to demo here is saving and loading to and from cassette. But in this case, it will be the PCUI. So I'm going to exit printer mode. I'm going to first load a program, for example. So I will type C load, quote, banner. So this will be, normally what would happen is I'd have my my PC-1 docked to a cassette interface or the printer cassette interface. I'd have my tape recorder ready to go. I would press the enter button, press play on the tape recorder, and load the banner that way. In this case, we're using the PCUI, so I already have the banner program saved on SD card. So I will then, so I typed C load banner. I will press enter on the Pocket Computer. Now it's waiting for the program. I will now go to the PCUI. I will click the send. I'm going to send a basic program, and we're going to send the banner program. And the PC-1 actually makes a sound. It has a buzzer in it, so you can hear the program loading. These are the tones, the FSK that's being generated by the PCUI. Okay, and we have the banner program loaded. So the other thing we can do for loading, the opposite of loading would be saving. So an example would be if I wanted to save this banner program back, or a program back to the PCUI, I would do the opposite. I would type csave, quote, I'm just going to type test. And in this case, because this model is a limited bus interface here, it doesn't work exactly like all the other Sharps. It's completely different. There's a second half of this video if you're really curious about the technical details. So it's not reliable to automatically detect receiving as it was on the other models. So on this one, you just have to push receive. It'll say waiting. I'll go ahead and press enter here. And you can see the PCUI has detected the transmission there. And the tones you're hearing are being generated by the PC-1. Okay, and the PCUI is just indicating that test has been saved. So what that means is that program now exists on the micro SD card. One of the other things that I usually like to see working and kind of required in many cases is the ability to save and load variable contents. So that could be done in a similar fashion. So for example, if I wanted to save the variables or load them to and from the Pocket Computer, with the PCUI, it's in a similar format. So for example, we would do an input, the pound sign, quote, and I could do ban mem, for example, which for the banner program, the font data I store in variable data. So what I'll do is I'll go ahead and press the enter key. So that's going to load variables from the PCUI into the PC-1. I'll hit send over here, and in this case I'll hit data and select ban mem. And that'll load like it did before, only in this case it's the banner font data. This takes a while. This is a full, unlike other models, you can't just send some variables. It's pretty much all or nothing, so it's got to send the entire variable space. So that takes a while. I think it's just over a minute or so. So one thing I wanted to point out is with the PCUI, when we send a program from a Pocket Computer to the PCUI, some Pocket Computers can send programs in ASCII mode, meaning it will send the text of the program and will save it as a text file on the SD card. This is a binary-only transfer mechanism on the PC-1, like many other Pocket Computers. So with the PCUI, what it'll do with the PC-1, like many of the other Pocket Computers, is when you send a program from the Pocket Computer to the PCUI, it'll store the binary image of that program on the SD card. It will also detokenize that basic program and store it on the SD card as a text file right next to the binary file. That way you can edit the program on your Mac or your Windows PC or through the web interface in the PCUI. And then you can send that text file, you could select a text file from the SD card and send it to the PC-1. Even though it doesn't support ASCII mode, the PCUI will tokenize that on the fly. So it's great to edit programs really quickly on your Mac or PC through the web interface on here. And you can send that program, it'll tokenize it, and then send it to the Pocket Computer. So you can see here that our variable contents have been loaded into the Pocket Computer. So that is the latest support now for the PC-1211. If I can get my hands on a PC-1210, I would like to test one of those as well. In theory, it should work. Note that this connection over here is not the same number of pins as the other Sharp models that I've demonstrated with the PCUI. There are fewer pins. It is nowhere close to the same interface type. So this is truly a unique line, this one and the other PC-1210. So definitely different. Was a challenge to get working, and this is now another model that I'm really, really happy to have support for printing and sending and receiving programs to and from the Pocket Computer Universal Interface. So stay tuned on the second half of the video. If you're more interested in the technical details of how I go about reverse engineering how this works with the original hardware and how we get these types of things working with the PCUI, stick around for the second half of the video. As promised earlier, this is a deep dive, a little bit of more of a technical discussion on the TRS-80 Pocket Computer, or PC-1, and some behind the scenes of how we got the printer and cassette interface capability on the PCUI. So how do we arrive at that? Well, I did a similar video explanation on the Casio PB100, very similar in terms of process of how to get here, how we got all the pieces working together. So starting with the PC-1, we have the 9-pin expansion port here, and normally this PC-1 would be plugged into the side, from the side here, into the cassette and printer docking station. There's also a cassette-only interface, which is, about 2/3 the size or length here. So that would be kind of similar, but to get printer support, we really need to see what's going on the bus for the printer. So just to kind of recap, we have the expansion port going into the breadboard here. So there's 9 pins here. So we're going into 9 consecutive spots here on the breadboard. And then the 9 pins that would have normally connected direct are also going into the breadboard. So those are lined up pin for pin. And then my logic analyzer here, I'm using only 7 lines, I think. Is that right? 6. Let me just count out loud here. Only 2 channels, so there's 4 per channel. So 1, 2, 3, 4, 5, 6, 7 lines. Seven signaling lines that we care about. So the other 2 looks like, let's see, 4, 5, 6, 7. We have a ground, a display ground, and I think 2 other VGG lines, etc. But anyway, we're looking at effectively only 2 channels here. So those going directly into the signaling that we care about on the bus. So we can see those roughly. If I kind of zoom down here, we've skipped a couple, right? So we don't need that ground line in the middle. We're only using effectively the data lines, inputs, outputs, that kind of thing. So the logic analyzer can then listen in to the communication between the PC-1 and its printer and cassette interface. So we can see the printer here, obviously, and then the cassette speaker and microphone connections are in the back here. I only have 1 plugged in here, and then I have a cassette recorder connected. So the process, usually what I do with these pocket computers, is I'll first get the cassette loading and saving working for programs, basic programs, and then I'll get the variables, if it supports variable loading and saving, memo, other types of data saving functions first. And so in order to do that, what I do is I'll go ahead and write a quick program. I'll save it to cassette. I'll come over here, record it. So it's going through the cassette interface while I have the logic analyzer recording. So at that point, it's able to sample, and if you look here, the logic analyzer here is going into this buffer. And I explained this on the previous video on the PB100 series, that if I connect the logic analyzer directly to the bus, sometimes it would pull the bus down too hard. It would load it down too much. So going through this buffer, it's the same buffer that I'm using on the PCUI. In this case, I use this buffer to translate between 3.3 volt logic and 5 volt logic, because the Pico is 3.3 and most of the Pocket computers are 5 volt. So I happen to be using the same. This is what I prototyped with, so I just saved this circuit that I built here, and then just created an adapter to put on the breadboard. So this side is let's see, where is this? I gotta figure out where these wires are going. Okay, this is the 3.3 volt side going to the logic analyzer, and on the Pocket computer side we have it at 5 volts. So it just kind of listens in on the bus and it does not interfere at all. So after saving, saving the cassette, we have a capture, and then what I'll do is I'll immediately play back that recording, switch it back to the speaker input here so that we're in the load phase. Go ahead and load the program from cassette back into the Pocket computer, and again capture the data. I'll repeat the same thing for saving variables just to see what that looks like in terms of the format. In this case, this saves all of the variables at once, so you don't specify, on other Pocket computers you could specify the variables that you're going to save and load. So you could do like an array, maybe a couple of arrays, a couple of variables. This is just all or nothing. So you just, A to Z, effectively, you just save the entire contents and load the entire contents. What's really interesting as kind of a side comment here on this model is it takes advantage, and I'm sure other models do this, I just never really paid attention to it. It appears, again, I think some other models do the same thing, but this one leverages the unused display RAM and the display controllers for the LCD for some of the variable contents, if not all of them. So, memory was very expensive back when these were made, so they made the most out of as much of the space as they could. So they had some extra space in the display controller, so the display controller holds some of the variable content. So I found that interesting. So after I wire this up and then save the captures, I usually at that point will go ahead and get the printer support working, and that's effectively similar. I'll go ahead and leave this connected to the real printer, and in this case you can see I was printing like Hello World multiple times, and then as it's printing, again I'll capture the bus and save that for analysis later. So effectively what I'm doing at this stage is just listening, recording everything I can see on the bus. Before doing any of that, however, what I usually will do is look at the service manual for the Pocket computer, if there is one. And in this case, we do have one available for the PC. This is the Sharp PC-1211, as I mentioned. There is a service manual available, and that service manual gives all the pin layouts of which pin label is which and what its basic purpose is, and you can tell a lot by the description. So, for example, the reason I do that in the service manual is because I want to know, most importantly, what my logic level ground will be. And it's not the ground you think it is. It's not necessarily GND on the, on the expansion port here. Oftentimes these are negative logic levels, so -5 and 0. And so there's oftentimes another ground reference point that would then invert that back so that you're seeing 0 and 5 volt logic levels. So most importantly, finding my reference ground for this type of circuit, and then second to that is what control signals do we need, both in terms of labeling each one of these as an input or an output for the Pocket computer, or both, depending on the mode. This luckily is a very simple bus interface, and it's not even technically a real bus interface, but very, very simple compared to the PB100, which is a Casio model that I did recently video on. So this one, I'll give you an example of why that has to be done up front. The PCUI has a bidirectional buffer. So I mentioned that one of the things it can do is go from 3.3 volts to 5 volts and back and forth. So it's a level shifter. It's 16 pins or 16 bits. and the chip is divided in half. So what that means is that you can have half of them designated as, in terms of direction, going this way, and the other half can go that way. They can all go one way, they all can go the other way, or they could tri-state. So this is a very good, simple buffer device for interfacing with something as complex as a PB100 series, where it actually has to be part of the bus, tri-state, take control of the bus, etc. And it's also good for simple interfaces as well. So you really want to avoid in a control situation where you have an input and an output on the same side of this buffer. So you can't switch each pin individually. You can only switch half the chip one way or the other. So if you need some inputs and some outputs at the same time, what you'll want to do is you'll want to make sure that they're on the right side of this level shifting IC. So the pins that we see here, this is the earlier stage before I make an interface pack, meaning something like this, that's, you know, designed for a particular pocket computer. You'll want to prototype that first. And so I'll usually just use these DuPont connectors and look at the service manual and figure out which way to go. Meaning, which side of the IC do I want these pins to line up accordingly. And if I make a mistake with that and say, oh, wow, I can't control one of these as an output at the same time that one is an input, I can switch the pins around a little bit and modify the firmware. So anyway, getting the, you know, the right pins, GPIOs to use for a given pocket computer, the most important thing right up front. Then I'm doing all my capturing at that point. So once I have all that done, at that point, we have all the analysis tools, you know, Python scripts and things like that to, you know, analyze what we know in the service manual, maybe what others have done on the cassette saving and loading, which in this case I had a lot of good resources for the tokenization and detokenizing, that kind of thing. A little bit of the representation of the data stream that might be appearing on this. Because there were some tools that would take WAV files. So if you were to record, if you were to save and load to a cassette adapter, but instead of hooking it up to a tape recorder, if you hook it up to a computer, you get WAV files or recorded audio files. There are utilities to take those files and convert them to and from text files. So those tools are incredibly helpful. And I've you know, given some credits to those that have worked so hard on those utilities a while back. They've been incredibly useful. Without that, what I would need to do is simply, you know, write a program that used all of the various basic commands available to discover all the tokens, you know, kind of reverse engineer that. It just adds more time to the process. So anyway, once we have all that information gathered up together, I can go through the firmware and just make sure that we are simulating exactly the same thing that the pocket computer needs to see. So a couple of comments on interesting comments I have on this particular model. This is nothing like the previous Sharp models that I've worked on for the PCUI. Nothing similar in any way. In one direction for cassette saving, it's serial digital data on one pin. So it's, again, fairly easy to write the firmware for something like that. But on the other direction, it's frequency shift keying. So it's not synchronous that way. When it saves and loads, it's using different encoding schemes there. One of them is more direct and digital, serial digital data. You know, the other one is FSK data, so you have to write frequency pattern matching and things like that. So that was kind of interesting. So the later Sharp models were all FSK input and out. So you just had to compare the two tones to determine the zeros and ones. But this one, in one direction, that's true, but in the other direction, it's serial data, which I found to be kind of interesting. And anyway, the other thing that was interesting is the printer format. Very easy to implement, just different in the sense that it certainly wasn't as complex as the Casio PB100 series, but it's kind of it's similar to the cassette mechanism, or the cassette serial data. It's similar in that sense. There's no clock on this. There's no clock on the bus, so you have to really get your timing understood pretty well, so that you can get the framing there without a clock. So that's always fun. And this printer is an interesting printer. It's actually an Epson mechanism, and it's a 4-wire, 4-pin, 4 horizontal pins, one right after the other, and this is a 16-character width maximum if you assume a 5:7 font with 1 pixel between the characters. And so it prints 1 row at a time. So the paper moves 1 pixel or 1 dot forward each time this thing goes back and forth. And it goes back and forth very, very quickly to print a row. So dot matrix, very interesting. It's the only pocket computer I have that has a dot matrix printer. The paper is simple, paper. It's not aluminum coated for the Spark printer. It's not thermal, unfortunately. And there is a ribbon, and it is replaceable, and they still make them today. So that's kind of surprising, actually. This is an Epson ribbon. So anyway, this printer is quite unique. But at any rate, this is a little bit of the behind the scenes of what this chaos over here is, and how we arrive at reverse engineering, the bus protocols, or tape loading, tape saving, printing, and getting that all working with the PCUI.